Hi, this lesson is on graphing quadratic inequalities. Today we're going to practice graphing less than, greater than, less than or equal to, and greater than or equal to. Now the steps to do these are here. And I'm going to have you stop for a minute and just read them over, and then we're actually going to just practice them. So just take a minute, read them over, and we'll start. Okay, so to get started, the first thing we have to realize is that we're going to graph the equality. So we're just going to pretend this greater than symbol isn't there and there's an equal to. So to graph a parabola that's in standard form, we need to find the vertex. So remember, to find the vertex, it is x is equal to minus b over 2a. And we're going to pull out our b and our a. b is negative 2. So this is a negative 2. A is 1, and that's 2 times 1. Negative 2 is a 2 over 2, so our x value is 1. Now we want to find our y value, and the way you find your y value is to substitute this 1 into our quadratic. So y is equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1. Minus 2 is negative 1. Negative 1 minus 3 is negative 4. So we just found our vertex, and I'm going to write it right here next to vertex so we keep it straight. 1, negative 4. Now to graph our parabola, well, we can start by graphing the vertex, but we need 2 more points to be able to graph the parabola. So we have the point 1, negative 4. 1, 2, 3. 1, 2, 4 right there. So that's our vertex. Now the nice thing about something being in standard form is we know that's our y-intercept. So we have one more point. So one of our points is 0, negative 3, our y-intercept. So I'm going to come over here and plot that. 0, negative 3. And then our last point is easy enough to find because we know that this is the axis of symmetry going right through the vertex. And if this is a point on this side of the axis of symmetry, then there should be another one equal distance away. So there should be another point right there. If I connect my 3 points, I should have my parabola. But before I do that, I need to come over and answer the question, is it a solid or dashed line? So I come up here and look, and it is a greater than. So if it's a greater than, not greater than or equal to, then it's a dashed line. So I'm going to draw this as a dashed line. Okay, now I need to decide, are my solutions inside the parabola or are they outside the parabola? So the way we figure that out is we take a test point. Now the easiest test point to always pick, if you can, is pick 0, 0. So I'm going to pick this point right there, and I'm going to figure out whether that's where the solution is. So I start by rewriting my equation. So I'm going to write y is greater than x squared minus 2x minus 3. And I'm going to put in 0 for y and 0 for x. And I get 0 is greater than negative 3. And you have to ask yourself, is that true? Is 0 greater than negative 3? It is. Therefore, that test point tells me that that's where my solution is. So I'm going to grab a highlighter, and I'm going to come in and fill that in. Now my solution is everything that's inside the parabola, but it doesn't include the actual lines of the parabola going around because it's not equal to. So it's everything just inside of it, but if I picked a point that was exactly on this, that vertex would not solve this thing. So if I put in the point, and let's test it, you can see, if I put in the point 1, negative 4, this will not work. So I'm going to put negative 4 greater than 1 squared minus 2 times 1 minus 3. Negative 4 is greater than 1 minus 2 is negative 1, minus 3 is negative 4. So you can see how the vertex doesn't work. Negative 4 is not greater than negative 4. So this does not work. So anything that's on the outside of this parabola is not a solution because it's part of the dashed lines. Okay, so example number 2 is actually a little bit easier to graph. Remember when we did transformations on quadratic equations, and I'm just going to show you down here. When we graphed the parent equation that looked like that, it had a vertex of 0, 0, and then we did transformations on it. Now, if it was y is equal to x minus h squared plus k, if there was a value inside there, it told us how to shift back and forth on the x-axis. If there was a value outside here, it told us how to shift up and down on the y-axis. This has a value outside of the parentheses, so it's telling us to go up on the y-axis. So we're taking the parent equation, and we're just going to go up on the y-axis for its vertex. So if I'm here, I'm going up 2, and there's my vertex. So it's a nice, easy way to find the vertex. So this is 0, 2. Okay, now I want to find some more points, 2 more points. And do you remember the 1, 3, 5 rule? So if there's a leading coefficient of 1, then it means I can go over 1 and up 1, and there should be a point there. And in this direction, I go over 1 and up 1, and there's a point there. Going over this way, over 1 and up 1, 2, 3. Oops, 1, 2, 3, and over 1 and 1, 2, 3. And there's my parabola, and I have my points. Now I need to decide whether it's a dashed or a solid line. So I come up here and look. There's a line underneath there, so that's telling me that it's a solid line. It's greater than or equal to. So I'm going to make this solid. Now the only problem with my test point now is that I like to use 0, 0. I can still use 0, 0 because it's down here. So I'm going to put that in. 0 is greater than or equal to 0 squared plus 2. 0 is greater than or equal to 2. Is 0 greater than or equal to 2? No, it's not. So it is a no. And if it's a no, then that's telling me that this point is not where the solution is. So in this case, again, the solution is inside. So I'm going to highlight inside. There you go. There's our graph number 2. Okay, graph number 3 is again in the form where it's a transformation. So we can pull our vertex out of there pretty easily. So step A says find the vertex. All right, so our vertex is the opposite of what's inside, -1, comma, -2. So I'm going to write that down here right next to it so I have it. And I'm going to come over here and plot it. So -1. Okay, example number 2 is a little bit easier to graph. So let's come up here and look at this one. It is y is greater than or equal to x squared plus 2. Okay, so this is one of those very simple equations because we can think of transformations. Remember those? We looked at the parent equation. So a parent equation looked like this for y is equal to x squared. And then as we move that parent equation by changing the vertex by h and k. So here we have no h value, but here we have a k value. So that's telling us to take that picture, that parabola, and move it up on the y-axis by 2. So we'd start here, our vertex would be there, and we go up 2. So our vertex was actually pretty easy to find. Our vertex was 0, 2. So our first step, A, vertex, was 0, 2. Now the other thing that makes this one very easy to graph is notice it's a leading coefficient of 1. So if you remember the 1, 3, 5 rule, so 1, 3, 5. So when it has a leading coefficient of 1, and I'm looking for additional points, I can start at the vertex, and you go over 1 and up 1. And you go over 1 and up 1, 2, 3. If you went over again, you'd go over 1 and up 5. You would find the next point. So on this side, over 1 and up 1, over 1 and up 1, 2, 3. So we just found our points. So that was very easy to graph. So our points, you can just go write those points down over here if you'd like. All right, next step. So points, dashed or solid. So I come up here and look. There's a solid line underneath that, so that's telling me that it's equal to. So that means I want a solid line over here. And the last step is I need to take a test point. Oh, second last step, I'm going to take a test point and figure out, am I going to shade inside or am I going to shade outside over here? So again, I'm going to take the test point 0, 0 because I'm very lazy and I will always go for it if I can. And I'm going to substitute 0 here. Greater than or equal to 0 squared plus 2. 0 greater than or equal to 2. Is 0 greater than or equal to 2? No. Therefore, that test point is not part of the solution. So that means that it's everything inside the parabola that I want. I don't want anything outside the parabola. And this time, it includes the sides of the parabola. So that solid line tells me that the vertex would actually solve this equation too. So this point will work, this one will work, this one will work. They'll all work in that inequality. Okay, let's try one that's a little bit harder. Okay, so again, the first step of graphing this is actually pretty easy. It is, again, in vertex form. So I can pull the vertex out very easily. It's the opposite of what's inside the parentheses. So my vertex is -1. And it's the same what's on the outside. Okay, so I'm going to write it down here so I just have it and I can see -1, -2. All right, next, I want to find some points. Okay, so the point I always think about finding is the y-intercept. And remember, the y-intercept is that point where x is 0 and there's a y value. So I'm going to figure out what the y-intercept is here. Y equals 2, and I'm going to substitute x for 0. Y is equal to 2. 0 plus 1 squared is still 1, minus 2. 2 minus 2 is 0. So when I put in a 0 for x, I get out a 0 for y. All right, so I'm going to place my first point here, list it there, and I'm going to plot my vertex too. So coming over here, I'm going to go -1, -2, and place a point. My other point that I just found is 0, 0. It's right there. And again, I can use the axis of symmetry going right through there. And if I know this point is 1 away from the axis of symmetry, then I should have another point 1 away from the axis of symmetry. So I should have another point right there. All right, so now we just need to decide solid or dashed. So I come up here and I look up, it's just a greater than. So there's no line underneath it. Therefore, I need to make a dashed line. All right, now I need to test inside or outside the parabola. So I'm going to choose a point. I'm going to choose, well, I can't choose 0, 0 this time because the parabola goes right over 0, 0, and I know it's not a point that's going to work. So I'm just going to pick one that's right there. Easy to see. It is -1, 0. So let's take that point, -1, 0, and we're going to put it into our equation. All right, y, 0, 2, -1 plus 1 squared minus 2. -1 plus 1 is 0, so this is gone. I have 0 is greater than -2. Is 0 greater than -2? It is, yes. Therefore, how do I shade? I shade where the point is. So if the point is true, I come up here and I shade this. Remember, in this case, it's a dashed line, so the actual parabola does not hold solutions, but everything inside that parabola, going on to infinity, not this way, does. I'm going to have to stop here, and to show you the system of inequality, it's going to be on the next video.